Welcome to Physics with Mr. Brazil. Today I'll be showing you how to use the Doppler equation, and I'm going to explain my technique, which I like to teach my students, and they tend to make less mistakes. So here we go. Normally when you go online or your textbook, you'll see that the frequency of the detector, okay, that's f sub d, that detector, that's either your ear, a microphone, anything that picks up the frequency. F sub s is the source. So that could be a light source or it could be a sound source. So it doesn't matter. Doppler applies to both light and sound. Now, we got this little fraction here. The v, the plain old v, that's the speed of sound or light. Okay, that's a constant for for sound for the particular temperature and for light for the particular frequency and medium that it's in. Now, you'll see a plus or minus. That's what most textbooks or online. And then v sub d and v over v sub s. Okay, and you got that v again, plus or minus. Now, my students get confused with that plus or minus, and they get confused direction. So I tend to do this a little differently. Okay, so I avoid this setup. And here's what I do. So I write f sub d, d before s, even in the alphabet. So again, frequency of sound, that's how I can remember the equation. And actually, I know that it's the velocity of light or sound. They come first, and then I'm going to use a minus only, And and how I remember again that it's v sub d over s is d is before s in the alphabet. And that way I can memorize the equation. Now, here's what I teach my students because the plus or minus tends to confuse folks. So what I'll do is I'll go like this. Let's say I have a stationary source. Well, that means it's essentially zero velocity, right? Because it's not moving. Okay. So no velocity. And let's say my detector is moving to the right, v sub d. Well, in this case, and I'm just going to set up the fraction, that would be v minus a positive v sub d. And actually, yeah, I'll just continue with what I'm doing here. V minus, and this would be zeros. I'm going to put the parenthesis on the outside. And that's your setup. You would just, whatever whatever v sub d is equal to, make it positive. Let's try this. Let's say I got v sub s again stationary, and let's get v sub d going towards it. Now, going to the left is a negative direction. Going to the right is a positive direction. Okay? And you're probably going, how are you doing this? Well, here's the deal. I make v sub s the 0th point, meaning like in a number line. Okay? You got a number line, there's 0. Okay? It's the 0th. Going to the right is positive. Going to the left is negative. So if v sub d is going towards s, it's going to be negative. Okay? Let me circle that so that you can see that. So if v sub d is going towards v sub s, that's a negative direction. Okay? So when I set this up, it's going to look like this. V minus, okay, a minus v sub d over v minus, and I'm going to put 0. And that's how you set up that fraction that you're going to multiply the frequency of the source. Here's another one for you. Let's say v sub s is moving to the right and v sub d is moving to the right. Okay, well, v minus, this is going to be a plus v sub d over a plus v sub s if it's moving also. And don't worry, check this out. If we were to go to the left, v sub s, and actually I'm going to share something after this. Let's go move to the left, v sub d, okay? Then v minus, so this is going to be a minus V sub D, and then V minus a minus V sub S. And it still works out. In this case, the source is moving to the left. It's going to a completely different direction. Now, somebody might say, hey, what if the question says, mentions VD moving this way and VS moving that way? Then just rearrange this so that VS is first. So in other words, rearrange that S is on the left. Excuse me, let me undo that. Okay, rearrange it so that V sub S is on the left and V sub D is on the right. And you can set up your equation. So in other words, I would make my V source, be it light or sound, come first. Okay, you might want to see an actual example. So let's do one for you. So I have a car that's going 24.6 meters away from the second car that's traveling the opposite direction, sounding a horn at 470 hertz. So what is the frequency you do that you do here? Okay. All right. So F detector dB4 S source V minus V sub D V minus V sub S, and that's how you memorize your equation. Okay. Now let's plug in our values. 477 hertz. Our speed of sound is 343 meters per second. 343 meters per second. Minus. Now, let's sketch this up so I can know what direction. So my source is moving away, so V sub S is going in the negative direction. And my detector is going the opposite direction also, so it's moving in the positive direction. So this is equal to 24.6 meters per second. So it's going 24.6 meters per second. I don't need the parenthesis, but I'm doing it so that you can visualize it. Minus, and now the source is moving a negative 25.58 meters per second. Okay, and the answer to this is 412 hertz. You can pause the video and punch that in the calculator to see. And that makes sense because they're going apart. And if you were to do the little circles, let me try to draw that a little bit better again. If you were trying to do concentric circles for the source, what's going to happen is that they're going to be a little more compressed up front and getting longer. Okay, and you are moving away, so this is going to be a stretched out effect, so your frequency is going to be a little lower, not higher. Okay, so keep practicing your Doppler equations. I hope this helped, and enjoy physics. Bye.